I'm Ayaka Sano from the University of Electrocommunications. Today, I will talk about mid-eye imaging technique for architecture in public space. Outline is like this. First, I'm talking about abstract. The purpose of our research is to design an optical system of forming mid-eye images suitable for public spaces. There are 3 design requirements. We evaluated luminance and resolution of mid-eye image. We prototyped 2 applications for proof of concept. Next is about background. Digital signage can change content easily. It can display appropriate content that varies depending on installation location and time zone. And digital signage is also used to improve the coloring of space. Projection mapping can change the actual environment by projecting new graphics on the surface of buildings. However, projection mapping also controls only the texture of the building, but cannot display an image detached from buildings. With the proposed system, we aim to present information in a place away from buildings. A mid-eye image is a real image that is reflecting and refracting light from the light source, and superimposing computer graphics on real objects is possible. Moreover, the image is seen without any specific equipment. Therefore, mid-eye image is promising for glass-free mixed reality. There are 3 methods of forming mid-eye images. From these, we decided to use micromirror array plates. MMAPs are expensive, but the brightness is better than with the AIRR, and the image quality is sufficient. One of the MMAP is AIP. As shown in the movie, it forms mid-eye images at symmetrical positions. Moreover, AIP forms large high-resolution mid-eye images. Next, I will explain 2 conventional optical mid-eye imaging systems. First is Mario. Viewer can interact with the mid-eye image in front of the imaging optics. However, since the optical components are not shielded, the optical system can be seen by the viewers. Next is about enchant table. This system was installed behind the table and hidden using a Louver film, and optical components are invisible. However, viewers have to adjust their line of sight diagonally downward to see the mid-eye image. Next is about proposal. There are 3 design requirements. First is the mid-eye image should be formed in front of the viewers, a little distance from the wall. By doing this, superimposing computer graphics on real objects is possible. Second is the mid-eye image should be displayed in front of viewers. If a system requires the viewer to look downward to see the mid-eye image, the viewer may pass through the mid-eye image without noticing it. In the worst case, another sign should be installed to make the viewer aware of the mid-eye image. However, if we make the mid-eye image visible when viewers face frontwards, they will be able to see the image even if they are far away. Therefore, we decided to present mid-eye images in front of viewers. Third is optical components should be invisible to the viewer. If optical components are installed in front of viewers, it is possible to view the mid-eye image in front of them, but the optical components are also visible. When the viewers can see the light source, they will not focus on the mid-eye image. Therefore, we need to hide the light source. This is our proposal system. This system satisfies the purpose and design requirements shown in this figure. The light from the light source is reflected by the AIP and goes through the Louver film. Then it reflected via reflective materials and forms mid-air image. There are three methods of shielding of optical components. The first method is using a filter that selectively transmits or absorbs light of a specific wavelength. However, such filters are not easily available due to high cost. The next method is using a polarizing plate. It is possible to hide the light-placing polarizing plate in the light path after the mid-air image has passed through the AIP. However, if we apply this method, viewers will see buildings through the polarizing plate, which will disrupt the field of view. The final method is using a film that transmits only light entering from a specific direction and diffuses or blocks other light. From these, we decided to use Louver film. Left figure shows the optical properties of Louver film. The film transmits only the light entering from a specific direction and diffuses or blocks other light. By using the film, it is possible to transmit only the light necessary for forming mid-air image and diffuses or shielded the light entering the field of view. Therefore, we used this method. Next, I'm talking about the angular design of display and reflective materials. The angular design, we treat display by theta and reflective materials by phi. Then the angle is that shown in figure. Thus, the following expression holds. We set theta is 40 degrees and phi is 25 degrees to fully use the light from display. Next, I'm talking about design of field of view. Since a mid-air image basically reflects the light from the light source and reimages it, its field of view is the range between the human eye and AIP. In the case of using reflective materials, the apparent position of the AIP and light source may be regarded as a position symmetrical to reflective materials. Therefore, the field of view with this system is the range represented in blue in figure. This figure shows the details of the proposed system implementation. We use high brightness display as a light source. We use Winkos view control film Y2555 as a Louver film. As shown in figure, the range of light from the AIP is between 40 degrees to 150 degrees. And the range of the undesirable light is 40 degrees to 55 degrees. Therefore, we used Y2555, which diffuses light of 25 degrees to 55 degrees. From these pictures, Louver film allows light to pass through to form mid-air image and prevents unnecessary light from passing through. Next is about evaluation. We evaluated by measuring the luminance and resolution. The purpose of evaluation is selection of suitable materials for our systems. There are many building materials with various glossy properties, and the luminance and resolution of mid-air images differ depending on the reflection characteristics of materials. Therefore, we evaluated the materials that can be used to form mid-air images with good visibility. We used 11 reflective materials. These pictures show reflective materials: transparent acrylic plate, white acrylic plate, black acrylic plate, mirror, combiner, whiteboard, high-gloss film, mirror film, touch display, porcelain tile, and wood. The measurement conditions are shown in left figure. The angle used for measuring luminance was 0 degrees to 20 degrees in 5 degrees increments. Since it is impossible to see a mid-air image if the angle used for measuring luminance are larger than 20 degrees, the measuring range was set to 20 degrees. The light source displayed white circle like center figure. We also measured how much luminance decreased by installing a Louver film. We used 3 reflective materials: mirror, transparent acrylic plate, and porcelain tile. The measurement condition is the same as luminance evaluation. The experimental results are shown in graph. A high luminance mid-air image was formed with glossy materials, mirror, combiner, and mirror film. However, because of the high reflectivity, they also reflected ambient light and showed the optical components and light source. From the above, we determined that they were not suitable for attracting people's attention to mid-air images. Therefore, we excluded these glossy materials. This graph shows the result of excluding the 3 reflective materials. We choose 3 reflective materials for our system. The first one was transparent acrylic plate. The plate is a transparent material that can be used for windows. The second one was the touch display. The touch display was selected because it is useful in combination with digital signage. The third one was porcelain tile. It is often used as a wall material in public spaces. This graph shows the result of how much the luminance varies with the presence or absence of a Louver film. When there was a Louver film, the luminance at 0 degrees was about 80%, without the Louver film. However, it was about 60% 20 degrees using the mirror and transparent acrylic plate. Next, we evaluated the resolution. We asked 8 people to participate in this experiment. We used 3 reflective materials we selected for the above experiment. We displayed black and white striped mid-air image shown these figures. Each participant completed 18 trials. We measured the resolution by using method of limit. In each trial, we asked participants to answer whether the image was visible. We randomly changed the reflective material and the stripe pattern for each series. The ascending and descending series were also randomly conducted. The measurement results are shown in figure. The numbers in the graph are the visual angles obtained by converting the average of the lowest thresholds when black stripes and white stripes were visible. The resolution of the mid-air image formed with porcelain tile was the worst. These pictures show the mid-air image formed using each reflective material. The stripe width was 5.5 millimeters. We confirmed the black and white striped patterns with the mid-air image formed using the transparent acrylic plate and touch display. However, we could not see the boundary of each line of the mid-air image formed using the porcelain tile. Next is about discussion. We realized the device that satisfies the 3 conditions described in the design policy. First is the mid-air image was displayed in front of viewers. Second, the mid-air image was formed a little distance from the wall. This movie shows the mid-air moon and real hand. But third is by installing the light source and optical components above the head of the viewer and using Louver film, optical components are invisible to the viewer. From the result, using transparent acrylic plate and touch display formed a high-resolution mid-air image. Therefore, complex shapes such as characters and pictures can be displayed on a signboard with mid-air images. using the percentile from the low resolution mid-tier image. Therefore, it is possible to display simple shapes such as numbers and English letters for digital clocks. The limitation of our system is brightness. It is impossible to form a mid-tier image with high luminance with this system. There are two reasons. First is that because it is necessary to select the reflective materials whose reflectance is not high. The second reason is that the brightness of the display is not sufficient. Next is about application. We make two applications. First is drawing tool. These pictures show example picture participants draw. And the second application is SantaCross, which means Santa Claus cross the front. Thank you. In this application, a CG Santa walks repeatedly from side to side. A transparent acrylic plate was used to the reflective materials. With our optical system, a vertical mid-tier image can be seen in front of a wall when facing upwards. In buildings, there are more vertical walls than tilting walls. Therefore, we believe that this design can be used in various places. That is all for my presentation.